Thank you very much for inviting me here, and I'm really excited to join this wonderful community. Usually in general audience conferences, I serve the dessert, but since we are all glycobiologists, so I think I'd better convince you of thinking about your food choices over lunch. So today I'm going to talk about immune responses against glycosylated biodevices, but also how our diet may also influence such issues. So the device that I'm going to talk about, it relates to bioprosthetic heart valves, and that relates to the fact that our heart allows unidirectional blood flow through the action of the different valves of the heart that allow the blood to flow to the lungs, and then from the lungs to the heart, and then from the heart to the whole body. But these valves tend to deteriorate over time in 2 to 3% of the population in people over 65. And what that means is that the valves get calcified, which then doesn't allow the valve to open and close rapidly as it would normally happen. And what we think is happening in the community is that there is some sort of inflammation that then drives some sort of inflammation, there are many hypotheses of what causes that inflammation, that then eventually results in fibrosis, that eventually mediates the calcification process that leads to malfunctioning of the valves. And then the patient has two options to choose from, either to select a mechanical valve or a bioprosthetic heart valve that is made up of animal tissues. And these bioprosthetic heart valves tend to deteriorate in time, and within 10 years, that patient has to go through another open heart surgery to replace the malfunctioning valve, because it would also have, oh, this is not working, wait. Yeah. If that is the opening and closing valve, and it happens hundreds of times per minute, after 10 years, it also has this sedimentation of calcium that doesn't allow it to operate properly. And these valves basically are made up of tissues from cows, horses, or pigs. And one thing, of course, that we hypothesized, is it moving? Stuck here. Oh. Yeah. So we hypothesized that these animal-derived tissues have carbohydrates that are non-human, because these are non-human tissues, and that would probably cause an antibody immune response against these non-human carbohydrates that would perhaps mediate the calcification process. And the two immediate suspects are the nu-5-GC, which is a non-human sialic acid, and the alpha-gal carbohydrates. Both are expressed in non-human mammals. Nu-5-GC is actually produced by all other mammals other than humans through the enzyme CMAH, while alpha-gal is also produced in all other mammals except human because of the action of the GGTA1 enzyme. But humans lack both these enzymes, therefore they cannot synthesize neither nu-5-GC or alpha-gal. But all other mammals, including the cows and pigs and horses that donate their tissues for BHVs, make these antigens. And these antigens are immunogenic in humans, which means that all humans have antibodies against both these glycans. And the alpha-gal antibodies are generated through the expression of alpha-gal antigen on gut microbiome, but all humans have circulating antibodies at certain levels. And the nu-5-GC, although none of the human tissues can produce nu-5-GC, we can consume it through our diet by consuming red meat or dairy. So all humans have these antibodies, and Ajit Varki at the time laid this hypothesis, which he referred to as xenosialitis, which is an ongoing war in our own bodies between the expression of nu-5-GC and circulating anti-nu-5-GC antibodies that recognize these antibodies as a non-self in the context of self. And he showed in mouse models that these xenosialitis process can exacerbate different diseases, including cardiovascular diseases and cancer. So we set up a hypothesis that these carbohydrates could also mediate inflammation and that would eventually lead to calcification of this bioprosthetic heart valve. So we set up a consortium where we had 13 different labs across Europe, US and Canada, and 5 different hospitals in Europe, and 3 smaller medium-sized companies that helped us collect over 5,000 blood samples over a period that we covered 15 years, 1 day before surgery, and 15 years up to at the end after surgery. And we had 1,700 patients that we tracked over time, 1 day before surgery, and then 1 month, 6 months, 12 months, and 24 months. And we really wanted to track the immune response as well as a echocardiography to monitor calcification. And of course, we had other groups where we recruited patients that had the surgery at least 5 years earlier, or those that were already diagnosed with calcification that had to go through the second type of surgery. So the first thing that we measured, that we noticed that within 2 years, both with the CT scan and echocardiography, we already noticed calcification. So something in these patients starts very early on to initiate the calcification process, and it doesn't have to happen 10 or 15 years later. And when we track the antibody responses in these cohorts, we first saw that in the initial inclusion, there was no differences in the antibody levels between the different groups, B1, B2, and A. And the alpha-gal antibodies were much higher compared to the anti-Nu5GC antibodies, almost 3 times higher. But when we then focused on the antibody with all the cohort samples through the kinetics, we noticed that there is some strong immune response in the B1 cohort in the early time points within the first 2 years. And this was statistically significant for the alpha-gal, but not yet for the IgG. So we then separated, of course, the control and the patients, and we tracked the antibody responses. Clearly, you can see that within 1 month, both the alpha-gal and anti-Nu5GC antibodies increased. They actually stayed high for 6 months, and both for the alpha-gal and Nu5GC. But while the alpha-gal then dropped, of course, it drops faster in the control patients. In the case of the anti-Nu5GC IgGs, these antibodies lingered even 2 years later at high levels compared to the controls. So something is going on with both these antibodies. Maybe alpha-gal is contributing to the initial stages, while anti-Nu5GC both to the initial stage and even 2 years later. We also were able to track the antibody levels in patients that have native normal valves, that are control patients that had either coronary artery bypass or that had the surgery with a mechanical heart valve that did not have any biological tissues. So normal native valves, we looked at the alpha-gal antibodies in calcified native valves or BHVs. The alpha-gal response did not have any differences between this group, but when we look at anti-Nu5GC response, we see an increase in the antibody levels as the calcification progresses. And of course, we have the Glycome microarray where we can monitor the antibody responses not against the total Nu5GC, but rather to specific antigens that contain terminal Nu5GC. And here you can see each line is a different glycan, and each column is a different patient at the different time points. And at the top, you see the BHV patients. Here are the control patients. And just by looking at that, blue is very low and red or white is high or middle. You can see that the BHV patients has a stronger immune response compared to the controls, also by the array. But another thing that we can notice is that there is not one specific glycan that contains Nu5GC that is increased, but rather the whole array of glycans, or in some patients, some of them are increased, but it's not specific to a specific Nu5GC glycan. And then, of course, we wanted to pinpoint that as a mechanism, whether really we have the contribution of the antibodies and the Nu5GC clashing to generate the inflammation that would cause the calcification. So, of course, the first thing is to see whether the tissues in the bioprosthetic heart valves contain Nu5GC, and indeed, we took commercial valves from several different companies that had tissues from either cows or pigs or horses, and any one of them had variable levels of Nu5GC. And even by immunohistochemistry, and keep in mind that these tissues are in fact treated dead tissues, because when they are produced in the valves, they are treated with glutaraldehyde or many different treatments to remove the protein antigenic moiety, but nevertheless, the glycans are still there. And you can see through the brown staining here the extent of level of Nu5GC expression here in one of the valves. This is the control staining. Here we have the anti-Nu5GC staining with inhibition with Nu5GC, but not with Nu5AC, so this is very specific. And this is with inhibition of Nu5GC glycans compared to Nu5AC glycans. So we see that the extent of expression is very high and covers the whole tissue. So I was asked by the physician, how do you know that in a patient, even 10 years later, the Nu5GC is still there? Perhaps in the body, it will be removed. So we took out explanted calcified BHVs, and then we analyzed the Nu5GC content in the lab, and we see that even 10 years later, we still detect Nu5GC in those tissues, at least 20% of the initial amounts. So this is one of the participating candidates, Nu5GC. What about the antibodies? So of course, we took out these tissues, and then we purified the antibodies from the explanted calcified valve. We homogenated the tissues. We used protein A to take out the antibodies and analyze it on glycan microarray. And sure enough, we saw that there is a strong and robust anti-Nu5GC response in those tissues, as you can see here. And these antibodies also, of course, expressed alpha-Gal because it is circulating in the sera. And when we looked at the possible mechanistic action of these antibodies, we looked at complement staining. And we noticed that in those explanted valve, we also see complement deposition, probably mediated by these antibodies that bind to the sugars. So I told you that Nu5GC, we cannot produce it, but we can consume it through our diet from red meat and dairy. So we hypothesized that perhaps also in the native calcified valve that initially caused the need for this surgery, they would also express Nu5GC. So we took up explanted native valves this time before the patient goes to the implantation of the bioprosthetic heart valve. And sure enough, you see through this very low brown staining that Nu5GC is there. We cannot synthesize it, so it's likely from the diet. And 21 out of 21 patients expressed these low levels of Nu5GC. Of course, it's much lower compared to the BHV, which is a native tissue that expresses the Nu5GC. And nevertheless, when we purified antibodies from this explanted valve, again, we could see antibody deposition in those explanted tissue. Just takes time to move. Yeah. And when we looked at immunohistochemistry, again, here we see complement deposition as well as TNF-alpha in those tissues, suggesting that the combination of antibodies and the Nu5GC in that tissue causes inflammation. Now, to take it to the next level, whether these antibodies also mediate calcification, we move to use the CMAH knockout mouse model, which is like humans, cannot produce Nu5GC. We generated small discs from the BHV tissue, and then we implanted it at the back of a CMAH knockout mice, but we pre-incubated the antibodies with either control buffer or with affinity-purified human anti-Nu5GC IgGs. We waited for 1 month, and then we explanted these tissues and measured calcification, basically calcium, through atomic absorption. And clearly we can see that in tissues that were pre-incubated with anti-Nu5GC antibodies, we see higher calcification levels. But in humans, it's a bit different because we already have circulating antibodies. We don't take out the tissue and pre-incubate it with Nu5GC. So to better mimic the situation, we actually generated glycone nanoparticles that either express Nu5AC or Nu5GC. We immunized these mice to have circulating anti-Nu5GC antibodies, and also we pre-incubated these small discs, again, with mouse sera that were immunized with Nu5GC or with controlled Nu5AC glycans. Here you can see that the antibody response is robust in the mice that received Nu5GC glycol nanoparticles. And at the bottom in purple, you see the control immunization. So in those mice, we have strong circulating anti-Nu5GC response against multiple presentations that contain Nu5GC. And sure enough, we see that only in the presence of circulating antibodies, we have higher calcification levels compared to the controls. And of course, that was also mediated with pig pericardium or with cow's pericardium. Irrespectively of the source of the tissue, the fact that we have both the antibodies and the sugar meeting together, that already mediated the calcification. And of course, we hypothesize that if we remove these sugars from the tissue, it will not mediate calcification. And one of the companies that we worked with through the consortium was able to generate knockout cows and knockout pigs, and we used the knockout pigs tissues. And although we had a very strong and robust anti-Nu5GC response, when you don't have the Nu5GC in the tissues, then that does not mediate higher calcification. So that can serve as a solution for patients where we can just use the source tissues that does not contain initially the Nu5GC. We also then went one step further to look at the level of antibodies that would mediate such calcification. And of course, if you see low levels of these antibodies, that did not mediate calcification. But if you had medium or high levels, that also mediated high calcification. So the level of antibodies, not only their presence, also matters for calcification. So going back to the hypothesis of Varkey that really circulating anti-Nu5GC can mediate or exacerbate different diseases, we were able to show that high levels of antibodies against Nu5GC was also related to higher risk of colorectal cancer. But in that specific study, where we looked at nurses' health study, we couldn't find an association with the diet. And it doesn't make any sense because diet is the only source to get these sugars in our body. So we set up another study to look at the connection between the diet and the levels of antibodies. So we know that red meat diet is associated with cancer. There are many epidemiological studies that show that. We know that the combination of Nu5GC and anti-Nu5GC exacerbate bioprosthetic heart valve calcification as well as cancer. But what is the connection between the diet? Does that matter if we eat a lot of red meat, would we have higher levels of antibodies? So initially we looked at the worldwide meat consumption in different countries around the world. And sure enough, you can see that in countries that consume high levels of red meat, you see that colorectal cancer association is increased. And of course, we find Australia, USA, South America countries over there, including Europe. But when we separate these countries into 4 quartiles, those that consume very low levels compared to those that consume high levels, and then we look at the antibody, colorectal cancer risk, we see that only in countries that consume high levels of red meat, we see that men has high risk compared to women, but not in countries that consume low levels of red meat. And perhaps that would be related to the fact that men consume more than women in general with higher BMI. So we decided to collaborate with a French group that had the Nutrinet Santé study, where people report online for 24 hours on their consumption levels of different dietary, whatever they ate over 24 hours, but they did it on multiple days that covered almost a month. And then France is also one of those countries that consume higher levels of red meat. And also in that study, they also showed that red meat is associated with higher risk of colorectal cancer and breast cancer. So first of all, we received common French food items to my lab, and then we measured Nu5GC levels in those different items. And based on the calculated Nu5GC levels, we separated almost 20,000 individuals that we have screened initially into 4 different quartiles based on Nu5GC consumption. And from that, we selected 120 representative individuals to also monitor their antibody responses over time. So you see the different quartiles. We had a group of 45 to 60 and another group of over 20, and we took 10 men and 10 women per quartile to look at the antibody responses. So initially, when we look at the red meat or the total new 5GC consumption, we see that men consume higher levels than women, and that is mostly associated through higher consumption of red meat, but we see also a dairy consumption. And sure enough, when we look at the antibody levels, we see that men had higher levels of anti-new 5GC antibodies compared to women. And this trend was also shown in the group of over 60, but we had much less individuals over there. We just had quartile 1 and 2 in those individuals, so that was not statistically significant, but the trend is there. We also examined the antibody response on the arrays, and we see that indeed in quartiles that consume high levels of new 5GC, we see an increase in the antibody response. So the more red meat you eat, or the more new 5GC in general you eat, the more antibodies you have. But that is not the case with a response against the human sugar in U5AC, or with an antibody response against alpha-gal that is not mediated through the diet, because that is expressed on gut microbiome. Then when we looked at the diversity of these antibody responses, here you see the different quartiles in men, 45 to 60. Again, they eat new 5GC mostly from red meat, and we see like a threshold effect that already within quartile 2 there is an increase in the antibody responses, and here each different line, a color, represents a different antigen with terminal new 5GC. And you see that there is a diversity in the profiles of these antibodies. And this is summarizing the linkage that we see in the antibody responses. So we see that while the low levels of red meat consumption leads to mostly alpha-2,6 linked sialic acids, so the antibodies recognize new 5GC in the context of alpha-2,6 linked. When you eat higher levels, it goes lower, and with increased recognition of alpha-2,3 linked glycans. And also, when we separate out these groups, we can see that that alone could separate out the different low level of consumption compared to high level of consumption. Also, the underlying skeleton had shifted throughout the antibody response in those that consume low levels compared to high levels of red meat. That was also replicated in the females, like women situation. We see that although women consume a half red meat and half from dairy, they all had this threshold effect, an increase in the alpha-2,3 linkage, and the shift in the repertoire of antibodies against the underlying structures. So one other control that we wanted to look at, there is the EBV infection that causes total antibody response increase. So we wanted to see whether this total increase in antibody in these patients would also lead to the shift from alpha-6 to alpha-3. We see that indeed in the infectious mononucleosis patients, there is a total antibody response which is higher. This is specific to new 5GC, but when we look at the repertoire, we don't see a change in the repertoire levels. So the shift between the repertoire of antibodies in low consumers to high consumers is really related to a new 5GC diet. We then took it one step further. We affinity purified these antibodies, and we looked at the total levels in those that consume low levels compared to high levels. We see that indeed the antibody levels are increased, and they're highly specific against new 5GC. We also see the change in the repertoire in these affinity purified antibodies, not only in the sera. And we can then also measure the affinity of these antibodies, and we notice that these did not have a change in the affinity of these antibodies. So just to take it, for the common knowledge, I was asked, what would be a safe level to eat red meat to be at the low quartile compared to high quartile. So we developed a glycemic index in which we actually measured the new 5GC content in different food items. And when we quantitated that if you eat 1 steak per day, that would put you at the low red meat level compared to 4 to 5 steaks per week, which would put you at the higher level. And then we compared each of these either food items compared to the red meat. So you can see that, for example, goat cheese has 3 times the amount of nu5GC in red meat. So that would mean you would need to eat 1/3 the amount to reach that high levels of nu5GC. And if we go back to the different countries around the world and we separate them according to that level of 120 grams per day, you see that that already increases the hazard ratio by 2.5 or 3, the higher the risk of incidence and mortality from colorectal cancer. So perhaps nu5GC and the anti-nu5GC provide a molecular link to explain the high risk of colorectal cancer, or perhaps even other types of cancer, when it comes to our diet and cancer risk. One last thing that I want to show you is that glycosylation on antibodies, as we have all discussed, is also changes depending on the production system. And if we produce antibodies against whatever, therapeutic antibodies in mammalian-derived tissues like rabbits or in mouse, then of course the glycosylation would carry nu5GC. And then when you have nu5GC that you, a glycoprotein, like an antibody that you use it to treat human patients, one thing that could happen is that you will have an increased antibody response. So in this case, we monitored 7 individuals that were treated with ATG, anti-thymocyte globulin, that was produced in rabbits. That antibody drugs contain nu5GC, and within 1 month, we see an increase in the antibody response. And as we saw for the biodevices, these antibody responses do not change. They increase within 1 month, and then they go down in some cases, or they remain even for 2 years. It's not against one specific glycan, but rather against a pool. And when we looked at the affinity in this case, we saw an increase in the affinity. So there is a difference between diet-derived antibodies and drug-induced antibodies or immunized antibodies. And when we took out these antibodies, we affinity purified it and exposed it to endothelial cells, we see a completely mirror image of a RNA-seq expression levels of these 2 different types of antibodies. So to summarize, I showed you that nu5GC is related to our antibody levels in the diet. The BHV cause increased anti-nu5GC antibodies that peak at 1 month, or ATG drugs can change the repertoire of these antibodies. And in vivo, in mice, we showed that they can mediate calcification, and they have differential effect between the diet-derived and drug-derived antibodies. So I'd like to thank my team and, of course, the consortium that I worked with, and I'd be happy to take any questions.